Okay, I'm going to take a minute to look at 2.1.3, where we really were looking at slope in a graph and how to find our slope for our equation. When I look at this first this first graph with all these lines in, and it asks me which is steeper, I'm not exactly sure if it's A or B, and that's where slope comes in really handy. Because the bigger the slope, that's a number measurement that we're going to give it, our rise over run, the steeper the line. And steepness is how vertical it is. So if I'm not sure, I can find that ratio of the change in y over change in x and see which one's bigger. So when I look at the slope for A, I'm going up 2 and over 1. I'm going to start here, going up 2 over 1, up 2 over 1. So my slope for letter A is going to be 2 over 1. Whereas when I get to B, to go from point to point, I'm going up 3 over 2, up 3 over 2. Now, these are ratios, but I could reduce them and look at them as fractions or as decimals because it just helps me to compare. So 2 divided by 1 is 2, and 3 divided by 2 is 1.5. So A is definitely steeper because the slope is bigger. Then deciding which is steeper, B or C. When I look at them, obviously B is steeper. Looking at the slope, going up 3 over 2, that's the slope for B. And then for C, the slope here is going up 2 and over 3, up 2 over 3. Remember, I'm always doing my rise first. And if I reduce these, this is 1.5 compared to 0.6 repeating. So B is the steeper one. The steeper the line, the bigger the slope. Now, when I get to D, this is a decreasing one, and they're going from point to point. Now, notice it's nice they have these marked. They have where the lines are going through certain lattice points. Even if they weren't there, I would still use these 2 points because they go through lattice points. Remember all these little points here, those are called lattice points. So I'm going down 1 and over 5, down 1 over 5. Even though it's called rise, I'm still going down 1, and my rise would be -1. Notice I put the negative with the change in y. Or you could put it in front. So because every time we read a line, we're going from left to right, your x, the number of spaces you move along your x-axis is always going to be positive. And then when I get to this last one, notice that I'm not going anywhere. So there is no rise, so that would be 0, and I just put a random number under 3. So this has a slope of 0, which makes sense. It's totally flat. There's no verticalness to it. So that would be flat, and that's what that looks like. All right, going to the next question. What's the difference between -3/5 and -5/3? Both of these are negative. They're both decreasing, but this -5/3 is going to be steeper because I'm going down 5 and over 3, where this one I'm only going down 3 and over 5. So the bigger the change, when I'm looking at the ratio, the steeper the line means that ratio between your change in y and your change in x. So when it comes to graphing, you should be able to, or hopefully getting to the point where if I give you an equation, you should be able to just graph it. This B is -1, so I'm going to start my line on -1. And my slope, notice I just have a whole number there. That's still a ratio. I can put that over 1. So this says I'm going to start at -1, and I'm going to go up 2 and over 1, up 2 over 1, up 2 over 1. So even though there's not a 1 underneath there, I could put this as a 1. And when we start talking about slope-intercept form, we like to have our slope in a fraction in that ratio because it gives us direction on how to get from point to point. Now, when we get to this one, we can use f of x instead of y. It's the same thing. My slope here, if I don't have a number in front of x, it's still going to be 1. Now, my y-intercept, because it's y equals mx plus b, my y-intercept is going to be -7 because this is the same as x plus -7. So I would start at -7, going up 1 over 1, up 1 over 1, up 1 over 1. When I get to this one here, it doesn't give me a y-intercept, so I could put it wherever I want. I kind of put it at 0 to start it out, but I know that I'm going to have to go down 6 and over 4 to get from point to point. But as long as it has that same slant, that same verticalness, it doesn't matter where it goes. Okay. And our last one, this one was a tricky one. So our change in x now is going to be 0. So our change in y is going to be 3. So I'm going to go up 3, but I can't move anywhere on my x. So this actually is a vertical line. And it's said that the slope is undefined because 3 divided